Today's notes are on statistics. Please note AP Psychology is not a math class, but you do need to have a working understanding of statistics to understand research studies and to do well on the AP exam. So, the first term we're going to talk about is something called measures of central tendency. The AP exam will likely use this term. It talks about stats, so the mean, median, and mode specifically. And that describes where the data falls in a distribution of scores. So for these notes, we're generally going to use test averages on an AP Psychology test as our example or means of reference. The mean is also known as the arithmetic average. So the average of a bunch of numbers. So you add them all up and divide by how many you have. So remember that very high or very low scores, though, can skew or distort the mean. And we'll look more at that in a little bit. The median is the middle score. So if I line up all of the numbers from small to big, it's going to be the very middle number. So half of the scores will be above it, half will be below it. The mode is the number that occurs most frequently in a data set. There are also measures of variability. So these scores look at how much variation there is in your data or how spread out your data are. The range is the difference between the highest and the lowest number in a data set. So if my high score on the last test was 100 out of 100 and the low score was a 65 out of 100, I'm going to subtract those numbers. And it tells me that the range would be 35. So the entire class scored within 35 points of each other, or 35% of each other. Standard deviation is something that you do not have to calculate in this class, but you do need to understand how it works. The standard deviation is the average difference between each individual score and the mean of all of the scores. So another way to describe standard deviation is how far on average each of the individual scores in a data set varies from the mean. So some people call this the average of each score from the average. Let's think of it in terms of a test again. If I give a unit test and there is a large standard deviation, that means there was a lot of variation in the scores. If the mean or the average was about 60%, but I have a large standard deviation, that means that some people scored very well, but some people scored very low. If I have a small standard deviation, let's say the average was a 60%, but a small standard deviation says most people scored close to 60%. There's very little variation between the scores. These bell curve pictures, the different color bands show different standard deviations. These are percentages that you need to commit to memory. In a normal distribution of data, so when data looks like we would expect it to, it is statistically normal. I have a mean or an average in the middle. And when I calculate standard deviations, down here it says -1 SD plus 1 SD. This means one standard deviation above or below the mean. 68% of the scores in my data set fall between one standard deviation on either side of the mean. 95% of scores or data in my set fall within two standard deviations of the mean. And 99.7% of all values in the data set fall within three standard deviations of the mean. Variance is another thing we can talk about. And this is the average of a distribution. So it's on average, how much do the scores vary in a data set? If the mean, median, and mode are all equal and located at the center of the distribution, the result is called a normal distribution or normal curve. It's the bell-shaped curve that test designers love. It looks like this. Data doesn't always look like this, but when it does, the statistics for it are very straightforward. In a normal distribution, the rule is 68, 95, 99, which is what we talked about previously with standard deviation. That means that most of the scores, 68% of them, fall in one standard deviation from the average or mean. 95% of people scored within 2 standard deviations from the mean. 99% of people score within 3 standard deviations from the mean. This rule allows us to comprehend that most people fall within average. Few people on an AP Psych test will score 100%, as well as few people are going to score 40%. Another example of how this works in everyday life is IQ. Statistically, we have very few geniuses and very few people with severe cognitive impairment in a population. The majority of people fall around average. We also talk about skews in psychology. So sometimes the graph looks like this. Looks more like a roller coaster than it does a nice hill. So when a set of data is skewed, it's not normal. So a positive skew says that most of the scores are low, and the skew, like the tail, points to the right. It points to the positive side of the x-axis. This likely means the test was very hard or too hard, where most people scored low. If there's a positive distribution, it says that there's an abundance of low scores. A negative skew says that most of the scores on a test are very high, and that the tail or the skew points to the left or the negative side of a number line. So a negative distribution means that there's an abundance of high scores. Inferential statistics are a little different than descriptive statistics. Inferential statistics ask the questions, can we make assumptions based off of our data? Are they significant enough to be applied to a whole high school or a whole nation? So there's something called statistical significance. This is a test that's generally run on a computer. There are several equations you can do to calculate it by hand. But when data is statistically significant, it means that this information is not likely to be due to chance. So when something is statistically significant in science or psychology, people take note because it says that the results are meaningful. The results aren't a fluke. It didn't happen due to chance. When we're talking about statistical significance, we have to talk about something called p-values. P-values are a way of determining if the results of the study are true or if they're random or due to chance. Once the equations are solved, you want a p-value of less than or equal to 0.05. So this says, if I converted this to a percentage, this says there's a 5% chance that the results are random. So this means that we are 95% confident that the results are accurate. We can also say the magical words, the results of this experiment are statistically significant. When designing experiments using statistics, there's 2 other things. The null hypothesis is something that researchers have to state that says there's no relationship between the variables. But their hypothesis states that there is a relationship between the variables. And if their results are statistically significant, they will be able to claim that their hypothesis is true. So there's a high probability when something is statistically significant that the independent variable caused the dependent variable. We can reject the null hypothesis, which basically says we can confirm that the idea that there is no relationship is false. We can reject the null hypothesis and say, yes, there is a relationship between these 2 variables. The probability value or p-value is less than 0.05. Please keep in mind that when the p-value is 0.05, it just says that there's a 95% chance that the IV, the independent variable, caused the DV, the dependent variable. It just says we're pretty sure. But someone will need to replicate this, and they'll also need to test it to make sure their results are statistically significant. Also know a p-value can never be 0. So we are never 100% certain. There's always a cause for kind of testing again and making sure. The lower the p-value, the better the data. You always want less chance and more statistical evidence when presenting data. Correlations, a perfect positive correlation is a full one, positive one, which says that both the x and the y-axis rise or fall together. A perfect negative correlation is a negative one, a whole number one, which says that the x and the y-axis rise or fall inversely. One goes up and the other goes down. If something is no correlation, it is 0. Any decimal in between can still be a positive or negative correlation. It just may be weak or strong, depending on whether if it's closer to 0, that means it's weak. And if it's closer to the whole number of positive 1 or negative 1, it's a strong correlation. And the last part we're going to talk about today are types of research. So I have correlational research, experimental, and descriptive. So correlational research, this is when you detect natural relationships. Nothing's manipulated. All you're doing is computing the stats and seeing if there's a relationship between these two factors. Experimental research can determine cause and effect, but you do need to change or manipulate one or more factors, and you need to incorporate random assignment, so assigning participants to either the control or the experimental group. Descriptive statistics or descriptive research is when you observe and record behavior. Nothing is manipulated, and this is generally a case study or a survey.